you wouldn't mind bringing the microphone down to the central aisle, and if people could converge on that if they had questions to ask. Please. Tell us your name and place.
Yeah. Chala Kumar from CAMD. First of all, thank you for this panel as well as the previous panel for enlightening me personally on various aspects of the telemedicine. This question, of course, specifically for you and anyone who can answer. If you're trying to, we understand the tools of the telemedicine, and we also know what nanotechnology can offer just by listening to various speakers in this conference. So can you speculate on how some of these nanotechnology tools that we have already discussed can be applied in order to solve some of the problems that have been mentioned in the telemedicine?
Let me just get the question right. You're asking how we can correlate the platforms and protocols that we're putting in for that with the more nano-based system
right.
that we've been looking at for the last day?
Let me rephrase it. How can the nano enable you to move the telemedical applications further or faster?
Well, I mean, it depends a little bit on how you do it. Like the last slide I showed is a couple of examples where we're going to try nano-based systems integrated on top of, for instance, a CMOS platform. So we have a readout circuitry that we typically run out through UMC or TSMC. On top of that, you could try to do nanowire sensing. You can try to make microbridges. You can try to do many nano-based sort of gas sensing, sweat, saliva analysis, integrated on a CMOS chip. That's where I think the first application will be, where the first link between nano and our sorts of platforms will be, to actually link these with the sort of in vitro applications that we've seen for the last day and a half. We'd have to find some way of communicating with them and bringing power with them, and I think some of the RF applications show ways to handle that. But you'll have to make it talk to the outside world some way.
Jim Leary at Purdue. Yeah, I think this is a classical problem that people in microfabrication have faced for a long time, that you have to go from the micro part of the project out to the real world. And I would submit to you that the same thing happens when you go from micro to nano. And there's certain things that you can and can't do. You can probably get power consumptions and things like that, and computing power in a micro device. You probably aren't going to get it in a nano device. On the other hand, nobody says it has to be autonomous. And I've been facing this when I've been trying to make I consider what I do as making nano devices. They're nanomedical devices. In fact, when I sort of gave that at a talk in Minneapolis at the Design of Medical Devices conference, they were a little startled at that, because I said, it's just another device. It's just on the nanoscale. But I think the thing that's important is to not get hung up about having to put everything into the nano. We're going to have that problem. It won't generate enough energy, although one could argue that in that environment, it doesn't need very much energy. And you could also say that you can make a cooperative medical device. I've been watching about implants of devices. That's really what we're doing, is we're doing implanting nano devices which collectively can function the same way as if you did an operation. And so I guess when I'm looking at this, I'm getting all kinds of transducing energy in, getting information back from nano devices for example, with MRI, with radio frequency pulses, things like this. There's ways to communicate in and out. And it seems to me a fascinating frontier that we start thinking about how do we make that interface between nano devices and micro devices in the macro world? Because once we do that, we're one step beyond wearing it. It can become part of us.
Other questions? You referred briefly to the continuous monitoring of drug compliance. And how effective has your device been? Or how widely used? Or is it still in development?
Yeah, this is in a development fabrication phase. We're trying to learn how to laminate different foils on top of each other and integrate that with a blister package. So it's really looking at how to make it and at the same time looking for the right partners to introduce it and test it. Yeah.
So the information that has been compliance would be from the package itself?
Yes.
And some kind of radio transmission?
Exactly, yes.
As I'm sure you know, the treatment of leprosy was a successful treatment of leprosy was in large part due to the compliance possibilities that just made all the difference in the world for that. And then also the big epidemic they had, well, in New York City, of drug-resistant tuberculosis in patients with AIDS, and that was true elsewhere. And many of these diseases that require chronic treatment would be greatly helped by a successful device of that kind. Brings a lot of interesting issues. You might even need some kind of satellite communication for remote areas. You know. Well, I'd like to thank all the speakers today. They've done